Okay, in the previous lecture, we have discussed the various MSDS information and the various information which is included in the various section. Okay, now in this lecture, we have discussed the fire triangle. Okay, what do you mean by the fire triangle? So basically, there are three components necessary to produce a fire. Okay, so the which main component? The first one, which is the heat. Then second one, which is the fuel, and the third component, which is the oxygen. Okay, and then chemical reaction which take place, right? So the three things must be present at the same time to produce a fire. It means that enough oxygen to sustain a combustion, then enough heat to reach ignition temperature, and some fuel or combustible material. Together, they produce a chemical reaction, that is a fire. Okay, so this is a concept of the fire triangle. Now, the various types of the fire. Basically, the fire which is classified in the 6 classes. Class A, which is it involving a solid material, right? Like wood, then paper, plastic, and the cloth. Okay. Class B, which is included involving of the flammable liquid like a petrol, oil, and the paint, right? Then class C, which involving a flammable gases. It means that a propane and aluminium and the titanium, right? Then class B, which include a flammable material like potassium, aluminium or titanium. Class E, which include electrical equipment, for example computers and the generators, right? And the type F, which include cooking oils and the fat and etc. Okay, so this is the classes of the fire. Now, the difference between the fires and the explosion. Okay, so the major difference between the fire and explosion is the rate of energy release, right? So the fire release energy which is slowly, whereas the explosion release energy which is rapidly. So typically on the order of the microseconds, right? So the fire can also result from the explosion, and explosion can result from the fires. Then a good example of how the energy release rate affect the consequence of an accident is a standard automobile fire, right? Then the compressed air within the tire contain energy. If the energy is released slowly through the nozzle, the fire is harmfully or deflected. Okay, deflated. Then if the tire ruptures suddenly and all the energy within the compressed tire releases rapidly, the result is dangerous explosion, right? So this is a basic difference between the fire and the explosion. Now, the next topic, which is a deflagration. Okay, what do you mean by deflagration and detonation? Okay, so first of all, we discuss about the deflagration. I already told you the main difference between the deflagration and detonation. So first of all, it is a subsonic combustion preparing through the heat transfer. Hot burning material heat the exact layer of cold material and ignite it, right? A deflagration is characterized by a subsonic flame propagation velocity, typically far below the 100 meter per second, and relatively moderate overpressure say below like 0.5 bar, right? Then most fire found in a daily life from a flame to explosion is a deflagration, right? For example, combustion in a gas stove, then fuel air mixture in IC engine, then rapid burning of the gunpowder in firearm, then pyrotechnic mixture in a firework. Okay, so these are the example of the deflagration. Then application in mining, demolition and stall quarry in a via gas pressure blasting. Okay. Now detonation, it means that it is a combustion propagation is a powerful pressure wave that compresses the unburnt gas and head to the wave at a temperature above the auto ignition temperature, right? So the velocity of the detonation in a solid and liquid explosive, it much higher than it is a gaseous one, right? And a detonation is characterized by the supersonic flame where the deflagration, which is characterized by subsonic flame, right? So the propagation velocity perhaps up to the 2000 meter per second and substantial overpressure up to the 20 bars, right? So the detonation is the most often used for the explosive and the acceleration of the project types. Plus detonation engines are the detonation wave for the aerospace proposal, right? Now, the main difference between the deflagration and the detonation, it means that the destructive blast force of a vapor cloud explosion depend in a part of the how quickly the explosion spread, and that is the rate of which its a flame from front travels, right? And the most of the accidental explosion, the flame front will travel relatively slowly in what is called a deflagration. For example, a typical deflagration flame front travel about 2.2 miles per hour or 1 meter per second, right? For intentional explosion, the flame front travel rapidly and with what is called a detonation. And the typical detonation flame front travel about 5600 miles per hour or 2500 meters per second. Okay. Now, the deflagration flame plus congestion or the confinement, it is called a detonation. It is a combination of these two, right? Okay, the next topic, which is BLEVE. It means a boiling, liquid, expanding, vapor explosion. Okay, so the flammable material which is stored under the pressure at ambient temperature, right? So the LPG or ethyl oxide bullet tank, right? For example, fire could start from external spillage or leak, and the flame impinge on the side of the vessel, right? So the metal of the heated vessel at high temperature become a big and finally rupture, allowed to contain or rapidly escape the forming a large vapor cloud and entrain the liquid, right? So the cloud then ignited by the original fire causally from the blast effect is due to the thermal radiation or the missiles, right? For example, Mexico City, which is a series of the LPG explosive at LPG gas distribution plant, resulting 542 killed and over 7,000 injured. So the LPG was stored in a 6-spear and 48 cylinder bullet holding 4 million gallons of the LPG, right? So the magnitude of the BLEVE, it means that the magnitude and the frequency, which is the piece of the container can shoot off the 100 of the meters, right? Then death from such missiles may occur up to 250 meter. Then fireball of 30 meter diameter is common. Then severe bomb damage in 300-400 meter radius is, right? Then shockwave from the BLEVE can break windows and several kilometers away. Then flame temperatures as a high like 1200 degrees Celsius. And then remember, there is a no safety period and BLEVE can occur at any time. Okay, so this is a BLEVE. Okay, the next one, which is UVCE. Okay, it is an unconfined vapor cloud explosion. Okay, so an explosion occurring in the open air, which result from the ignition of the flammable gas. An unconfined vapor cloud explosion may result from the accidental release of the flammable liquid or a gas. Okay, so the example of the UVCE, which is the Flixbor plant producing the caprolactam for nylon manufacturing, and part of the process involve reaction of cyclohexane with air. So the massive failure of a temporary bypass pipeline caused 40 to 50 ton of liquid cyclohexane to escape and form a large vapor cloud, right? So the subsequent explosion caused damage up to the 3 miles away, and the 28 killed person which is killed, and 36 which is injured on the site, and 53 which is offsite injured, right? It is due to the unconfined vapor cloud explosion, right? Now, the next one, which is the safety relief valve. Okay, what do you mean by safety relief valve? Okay, here you can see that the figure which is given, right? Okay, so it is a type of the valve used to control or limit the pressure in a system or a vessel which can build up by the process, upset or instrument or equipment failure or the fire. So the pressure is relieved by the allowing the personalized fluid to flow from an auxiliary passage out of the system. Okay, here on screen you can see that the number 1, which is the inlet nozzle. This is the inlet nozzle, right? Then valve seat. This is a valve seat. Then 3 number, which is a seat holder. This is a seat holder. Then 4, which is valve body. This is a whole valve body. Then 5, which is a seat pressure adjusting screw. Okay, here you can see that this is a adjusting screw. Then 6, which is this is a cap provided for the protection. Then 7 number, which is spring. Here you can see that the spring is given. Then bonnet. 8 number, which is a bonnet or body. Then 9 number, which is a seal. Okay, so this is a component or part of the safety relief valve, right? Now, the operation or construction of the safety relief valve, which is, so the safety relief valve will start to open, reach, fulfill, lift and close over the range of the pressure. So there are 3 pressures that are important when specifying a relief valve. Okay, here you can see that the 3 pressure, which is relieving pressure, set pressure and the reset pressure. Okay, so what do you mean by set pressure? This is a pressure at which the safety valve will begin to open, right? Set pressure, it means that the valve will be open, right? Then relieving pressure, it means that this is the pressure at which the safety valve is fully open and working at a full capacity. Okay, the relieving pressure, it means that a overpressure. It is called overpressure. And at this condition, the safety valve is fully open and the working has a full capacity. Then reset pressure, it means that the pressure at which the safety valve which is closed after the relieving event. Okay, so this is a blow down. It means that here the safety valve will be closed. Okay, so this is a construction and operation of the safety relief valve. Now, this some important definition, which is pressure relief valve or pressure safety valve. So the difference between the pressure relief valve and the safety valve is have a manual lever to activate the valve in case of the emergency, while most relief valve are spring operated. At the lower pressure, some use a diaphragm in the place of the spring, right? And the oldest pressure relief valve design used to weight to seal the valve. Okay. Then relief valve, it means that it is a valve used on the liquid surfaces which open proportionally as the increasing pressure overcomes the spring pressure, right? Then safety valve, it is used in the vapor gas services, and most of the safety valve are full lift or a snap acting, in that they pop up completely open, right? Then a safety relief valve, it is a valve that can be used for the gas or liquid services. However, the set pressure will usually only be accurate for one type of the liquid at a time, right? So this is all about the safety relief valve. Okay, so this is all about the today's lecture. I hope you all understood about the today's lecture. Thank you for the watching. Thank you.